So welcome back. This evening we're going to work with some word problems, and specifically we're going to use a strategy called a proportion to solve these word problems. So some word problems fit this category nicely. Again, a proportion, remember we said it's going to be like a fraction equal to a fraction. And we're allowed to what we call cross multiply to strategize and get that into a form that we can solve. So let's look at an example of a word problem that you could use a proportion with. So if you can buy 1 can of pineapple chunks for $2, then how many can you buy with $10? Again, word problems kind of freak people out, but you just have to read it and take it piece by piece. The key thing is just define the question. Most time the question's at the end. So what we're asked to do is, how many cans can you buy with $10? So how many can you buy with $10? So that's what we're looking for, is how many cans of pineapple chunks can you buy with $10? So then from there we need to look for the information. So we're looking for some of the math in the problem. And what we can pick up on is, as far as the math goes, we can see that there's going to be 1 can goes for $2. And again, we're also trying to figure out how many can we get with $10. So again, notice how they kind of disguise one of the numbers. 1 can, remember that represents the number 1. 1 can go for $2, then how many can we buy for $10? So 1 can goes to $2, we can what we call write a ratio. Those two numbers kind of work together. A ratio is, again, it's a special fraction. So what I can do is write this 1 can kind of go with $2. So I can write that as what we call a ratio or a fraction. A lot of times I like to keep the labels with it, so that 1, we actually write that number, the word can with that, and the 2, we write the actual dollar sign there. Now, when I come over to this other side, what we're trying to figure out is how many can you buy with $10. Notice the $10 is the money. And what we're looking for is, how many cans can we buy for $10? So this actually plays out as a proportion. So how many cans goes to $10 is also another ratio. And these two ratios, what we're trying to do is try to make them equal. So we know that in a ratio, to make them equal, this cross product has to equal this cross product. So 10 times 1 must equal whatever 2 times x is. So I'm going to write that then as 2 times x. Let me do that in, let's do that in blue. So we have 2 times x has to equal then 10 times 1, which is 10. And then I can find for x by recognizing that since this is multiplication, I can think backwards using the inverse operation. And since we saw multiplication, this is a signal that we can divide to find what x is. So I know x is going to equal then 10 divided by 2. And therefore we end up with 5. You may also be able to just see that, 2 times what number is 10? 2 times 5 is 10. But we also could just use the strategy of division to find that answer. So it would be, so 5 cans would end up being the answer to that problem. So if I can buy 1 can for $2, 5 cans should be going for $10. That should make sense there. Let's look at example number 2. If you can buy 4 cloves of elephant garlic for $8, then how many can you buy with $32? Again, in a word problem, the first thing you have to identify is what the question is. So always kind of make a note of that or underline it. So how many can you buy with $32? That's what we're looking for. So how many, and again, what they're looking for, I guess, how many clothes can you buy for $32? So how many clothes can you buy for $32? So that's what we're looking for. Again, I also have to kind of find where the math is. So pick up on that there are 4 clothes go for $8. So that 4 clothes goes for $8. And we know that we have to end up with this 32 altogether. Now in proportion math, we pick up on that this 4 clothes kind of goes with this $8. So we can write what we call a ratio. Write those as a fraction. So 4 clothes, and I'm going to use the number 4 clothes. And that goes for $8. And over here we're looking for how many clothes can we buy for $32. Again, the labels have to match up. Since I went clothes to dollars, this side here has to also be clothes to dollars. And that's kind of the cue that you set your proportion up correctly. Now once I have the proportion set up, we learned that we just cross multiply to find the answer. So 8 times some number has to equal 32 times 4. Well, 32 times 4, well, that's 4 times 32, which is 30, 30 and a 2. I can use the rectangular model to multiply that out, because we know that 4 times 30 would be 120, 4 times 2 is 8, and 120 plus 8 would be 128. So I've got that. Now I have to recognize what can you multiply 8 by to get 128. Remember, we can also go backwards and divide. So we know that x has to equal 128 divided by 8. Now, instead of dividing by 8, I could recognize that, hey, I can divide those both by 2 since it is a fraction. Half of 128 would be, looks like 64. And half of 8 would be 4. And since those are still both even, I can divide those both by 2. Half of 64 is 32. Half of 4 is 2. And I actually can divide each one of those by 2 and get 16. So x would equal then 16 clothes. So I'm just using the path of least resistance. I really am not real good with dividing by 8. But I can recognize that since these are even, I can just divide the numerator and denominator both by 2 and work my way down, and it actually just turns into a whole number. So let's look at this next example. The currency for Argentina is the peso. The exchange rate is approximately $3 is going to equal a peso. At this rate, how many pesos would you get if you exchanged $121.10? So again, we have to find the question. The question would be then, how many pesos would you get if you exchange, $120.10? So there's my question. Now I'm looking for the math. There's not much math in this problem. The only thing I'm seeing is there's $3 for every peso. So this $3 is equal to a peso can also be written as a ratio. So I write that as $3 goes along with, so $3 goes along with 1 peso. And that ratio can now become a proportion because what I'm looking for is how many pesos can I get for $121? So notice how I went dollars to pesos. So $121.10 is going to get me how many pesos. So there's my math. And then what we pick up on is in a proportion, we can kind of cross multiply to get the math to play out. So we end up with then 3x, so 3 times x has to equal then 1 times $121.10, or we're just going to leave the dollar sign out and just write that as $121.10. Now to get our answer, we still got to use backwards thinking. Since this is multiplication, we can use division to find the answer. So x is going to equal 121.10 divided by 3. I can't do that math in my head, so I'm going to use long division. So the 121.10 goes in the little box, the garage, if you will, and the 3 goes on the outside. So we call it that rain game. The guy getting rained on goes inside the garage, and this becomes our divisor. So if we play the math out, we see that 3 does go in 12 4 times, and 4 times 3 is 12. And 12 minus 12 is the remainder of 0. I slide the 1 down, but 3 does not go into 1. So I have to put a 0 here and slide the next number down. So 3 goes to 11, looks like it's going to be 3 times. So I have bring the decimal up there. 3 times 3 would be 9. 11 minus 9 would be 2. And since we got a 0 here now to slide in, we slide that 0 in. 3 goes to 20. It looks like 6 times. 6 times 3 is 18. Get a remainder of 2. So it looks like we're going to get that repeating decimal again. So I guess basically what I got to figure out is, looks like pesos, if I'm looking for the whole peso, I can't get 41 pesos. I'm getting basically about 40 pesos. Okay, so I could say about approximately 41 pesos as an answer there if I'm looking for whole numbers. I'm sorry. Actually, I can't go to 40. I gotta round back down to 40. I don't have enough for 41, so approximately 40 pesos. If I'm rounding it to whole pesos. So it wasn't real clear on what kind of answer we're looking for. I don't know if pesos go in decimal form. So I'm thinking, for this example, 40 pesos would be an estimation. We'd have to have a little bit more of a discussion to really answer that question a little bit more. So that'll do it for right now. So notice how, again, proportions can help us solve some of the word problems that are out there. Stay tuned.